Okay, so this is the last question, question 10 for today, which is a function question, which you guys love. So we've been given the function as being x squared plus 4x, and the domain at the moment, we don't know what the value of c is. We know that, we don't know what the value of c is, but we do know that the function's 1-to-1. So what that tells us is that we know that this is a positive parabola, which means it looks like that. And our value of c, for it to be a 1-to-1 function, is going to have to be at the smallest it possibly can be, is at the vertex, and it can be any value to the right of that. And that would ensure that we've only got this side of the parabola, or it might start a little bit over, but it means that it will be 1-to-1, which is what we want for it to be a 1-1 function. Okay, so if we go back to our function, we are asked for part 1 to do two things. State the range of f in terms of c, and we're asked to find the smallest possible value of c. So I'm going to start with the second part, which is to find the smallest possible value of c. That's pretty straightforward. All we're going to do for that is complete the square, because normally if we're asked to do things to do with domain and range, we would complete the square anyway and to find the vertex. So if we go ahead and complete the square, we'd take half of 4 as the coefficient of x there, which is 2, we'd square it, and straight away we'd take away 4, which is 2 squared. And that means that when we expand this, we'll get this. So that tells us that this vertex here is at the point -2, -4. So what that tells us is that our c value at the smallest can be -2. It could be -2, -1, 0, or some decimal value in between it, but we don't want it to be less than -2, because otherwise then we start to fold back up on here, and it won't be 1, 1. Okay, so our smallest possible value of c is -2. Okay, or it could be anything above it. Okay, so now we found the smallest value for c, which is -2. We go back and it says state the range of f in terms of c. So in this case here, all that's asking you to write here is that the range is that it's going to be greater than or equal to c squared plus 4c. So all I've done is taken the original equation and replaced the x's with c. So you think, oh, why does that work? Well, if we go back to this vertex one here, if c was -2, to find out where what the y value is at that point, you would just put it into the equation, work that out, and that would give you your y value. So let's say the c value was, in fact, 0. If I put 0 into x squared plus 4x, then I'm going to get a y value of 0. And that means that the function only exists for y values of 0 or higher, right? So that's how we get this function in terms of c. The range in terms of c. Okay, so let's try puppy and wrap this question up. So we've got two functions. We've got the g of x function that's just given us now, which is ax plus b. And we've got domain for that is that x is bigger than or equal to 0. And we've got the function from before, which is f of x, which is x squared plus 4x. And they've told us that c equals 0. So that means our domain for this one is also x is bigger than or equal to 0. We're trying to find the values of a and b are both positive. So I'm going to write that there as myself as a note for later. If it was the exam, I'd highlight those words on the paper, just so I don't forget. They don't normally tell you stuff in your question if they don't want you to use it, so we'll just leave that there for later. Okay, we know that the g of f of 1 equals 11 and the f of g of 1 equals 21. So let's set up what the g of f looks like. So the g of f of x, you get that by putting this function here whenever you see x in the g of x. So you're basically substituting this into this, which is why I've written this one inside of this bracket here. So the g of f of x looks like this. We replace the x of the g of x with x squared plus 4x. and then we add on b like that. And then our f of g of x is the other way around. So in this case here, we're going to replace any x's we see in this function with this whole expression here. So we're putting the g of x, we're putting it inside of the f of x. So that means that we're going to get, first of all, we're going to replace the x and the x squared with ax plus b, and then square it. And then we're going to replace the x with the 4x with ax plus b, like that. Okay, then we can set up two equations using what they've told us. So first of all, they've told us for the first composite function here is that when x is 1, this composite function equals 11. Okay, that's this one here. So if I put x as 1 into that equation there, it should equal 11. So 11, I should get that by replacing all of the x's here with 1. So if I replace x squared, x with a 1 and then square it, I get 1. If I replace 1 for 4x and times it by 4, I get 4. So I get 5 there plus b. Okay, so that's 5a plus b. So 5a plus b equals 11 for the first one. And for the second one, this is supposed to equal 21. And again, if I substitute 1 into that composite function, it's supposed to equal 21. So let's go ahead and put in 1 there. So if I put 1 as x into here, I'm going to get a plus b, all squared. And if I put 1 into here, for x, I'm going to get a plus b. But this time it's going to be 4, lots of a plus b. Okay, so now we're going to come up with a way to solve this equation. We've got two simultaneous equations. We've got two equations in a and b, and we have to find a way to make one equation that's only in one variable, either a or b. Okay, so I'm just going to move things up a little bit so that I've got a little bit more space to work with. Okay. Cool, so how do we go about getting one equation with just one variable? So we've got to find a way to either substitute in or eliminate that variable so that it is only with one unknown. So I'm going to try doing some substitution. If I take this equation here, 5a plus b equals 11, I could rewrite that as b equals 11 minus 5a. And then what I could do then is whenever I see a b in this equation, I could replace it with b 11 minus 5a. So why don't we try that? So 21 equals a plus 11 minus 5a, all squared, plus 4 times a plus 11 minus 5a. So all I've done is replace the b's with 11 minus 5a for both of those ones there. It does now involve quite a bit of sort of expanding and grouping of like terms. Before I expand this one out here, I can see that inside the bracket I've got a minus 5a. So if I was to tie that up first, that would become 11 minus 4a inside the bracket there. And same thing over here. If I was to tidy this one up here before I expanded it, I've got a minus 5a. So I would have 11 minus 4a inside the bracket there as well. Cool. So let's go ahead and expand those brackets. So the first one here is going to be 11 times 11, so 121, minus 88a plus 16a squared. And then over here we're going to get 44 minus 16a. And then what we have to do now is rearrange it, put it into that whole ax squared plus bx plus c equals 0 form, because it is a quadratic, and that means that we can go ahead and we can solve it by factorising. Hopefully we can factorise it and find the solutions that way. So let's tidy this all up. So if I move everything to the right hand side and make left hand side 0, I'm only choosing the right hand side because it's already positive for a squared on that side, so it makes sense. So 16a squared. If I group up all of the a terms, I get negative 88a, take away 16a. So I get negative 104a. And then with my terms, I get 121 plus 44, so 165, but then I'm taking away 21. So I end up with 144. Okay, and before I try to factorise that, I can see that I've got probably some sort of common factor there that I can divide through by. So let's try that. So fortunately, I can divide through everything by 16. So if I do that, 104 divided by 16 is 65. And 144 divided through by 16 equals 9. So whenever that happens, I always look back up at my stuff up here and think, oh, was there something I could have done earlier that would have prevented me having introduced all of this, the 16 factor down here? Somewhere I could have prevented that earlier in the working, just to save myself some time. And there probably will be a way up here somehow that I could have divided through earlier by something. But anyway, we'll move on. Okay, so now I've got my quadratic here. I've got to find my two factors that are going to make this work so that I can solve it. I just realised when I went to sort of factorise this that I've obviously written that down wrong. It's 6.5, not 65, and that actually makes it not so nice. So I'm going to actually just rewrite that back to 2a squared minus 13a plus 18 instead. That'll make it a bit easier to factorise. It's my eyesight. Anyway, so if I try to factorise that, I'm going to have 2a and a. I know that my I've got to have a negative 13a, so this is going to be either negative 3 and negative 6, or negative 2 or negative 9. And if you have a bit of a think about it for a second, you'll realise that negative 9 and negative 2 are the ones that you want. And you want to have negative 2 over here and negative 9 over here. And that way you'll get negative 13a when you expand that out and factorise it. Okay, so that means that we've got two possible values for a. Both are positive, which is what they have to be. They're supposed to be positive. So we've got that a for one of them can be 9 over 2. Or we've got a could be 2. So that's our two a values. But the party's not over because we haven't found the b values yet. So we can use this nice expression here to work out our b values. So if we start off with the a equals 2, 1, if I put a equals 2 into here, I get negative 5 times 2, which is 10. So 11 minus 10 would be 1. So that means when a is 2, b equals 1. And then for this other one here, a equals 4.5, or 9 over 2. When I put that up here, I actually end up with negative 20 point something. Anyway, it's bigger than 11, so I actually end up with a negative b value, which is what we're not supposed to have, a negative b value. They told us at the beginning that a and b are both positive. So what that means is that that combination there, it doesn't work. So that means that our values for a and b are a is 2 and b is 1.